Students, in this video, I'm going to go over exercise U3A01B, which is taken directly out of our Envision textbook. The pages from the Envision textbook is 164 to 165. Let's take a look. All right, so the topic associated with the lesson that's embedded in this assignment involves isosceles triangles and equilateral triangles and the different various properties that come along with it. So the first question here reads, how are the side lengths and angle measures related in isosceles triangles and in equilateral triangles? Well, simply put, this is the diagram that they're really looking for. That if you have two sides that are the same, that justifies that this is an isosceles triangle, and the base angles of the triangle are going to be congruent. In an equilateral triangle, all the angles are going to be the same. So those are the side-to-angle relationships. Error analysis. Nate drew the following diagram to represent an equilateral triangle and an isosceles triangle. What mistake did Nate make? So I see here that in order for this to be true, let's see here. That means this angle here is 60, this angle is 60. And if that is the case, then these two angles must add up to 80, and these two angles add up to 80. The mistake that he made was the sum of angles does not add to 180. Here in this case it only adds to 160, the ones that are circled there. How can you distinguish the base of an isosceles triangle from a leg? Well, the base is always opposite of the vertex. So which one is the vertex? The vertex is the angle that is not congruent to the two base angles. So that's one way of thinking about it. Another way of thinking about it is the side that contains, or it's the included side with the two base angles. So an alternative way of thinking about it is the side, the included side, formed by the two congruent base angles. What do I mean by the included side? Well, it is the side that's in between the two base angles, right? So the included side is the side that's in between the two base angles. All right, question 4. Is it possible for the vertex of an isosceles triangle to be a right angle? Yes, it is possible. Explain why or why not, and state the angle measure of the triangle if possible. So the vertex, if this is 90, and if this is indeed a right triangle, an isosceles triangle, that means these two angles must be the same. So I can have 2x plus 90 is equal to 180. Subtract 90 from both sides, I get 90. Divide by 2, I get x is equal to 45. Therefore, an isosceles right triangle will always have angles of 45, 45, 90. Always. All right, number 6. Find the unknown angle. So since this angle over here is 69, that means this angle here must be 69. And I am not sure which unknown angle they're asking for here. So I'm just going to find all of them. If that's 69, then that means this angle over here must be 180 minus 2 times 69. That means it's 180 minus 138, which is going to be 42. So angle A is equal to 42, and angle B is equal to 69. So if that's 77, that means the two base angles there are going to be the same. So 2x is equal to 103. Subtract 77 from both sides. Divide both sides by 2x. I end up with x is equal to 103 over 2, or 51.5. Okay, so I'm given information about sides now. So if this is the case, these two angles are the same. That means these two sides are going to be the same. So 35 is equal to 3x plus 8. Subtract 8 from both sides. I end up with 27 is equal to 3x. Divide by 3, x is equal to 9. And since x is equal to 9, GH, therefore, is equal to 6 times 9 is 63. I'm sorry, 54. 54 minus 5 is equal to 49. That's 49. This, without any work, is equal to 35. Alright. Again, same idea. 26 is equal to 2y plus 8. Subtract 8 from both sides, I end up with 18 is equal to 2y. Divide by 2, y is equal to 9. Since y is equal to 9, and by the way, this is equal to 26, then that means this is equal to 27 minus 7, which is equal to 20. What is angle ABD in the figure shown? Angle ABD, so this is an isosceles triangle. This is 71, and the angle and the vertex is bisected. So therefore I can say that this must be therefore a 90-degree angle. So that x, I'm going to call this angle here x, right? X plus 71 should equal to 90. Subtract both sides by 71, I end up with 19. X is equal to 19. So that means this is going to be 19 degrees. ABD, whoops, is equal to 19 degrees. Okay, find the unknown angle measures in each triangle. Alright, so this is 51, that means this is 51, that means this angle over here must be 180 minus 2 times 51, which is 180 minus 102, which is 78. These are going to be the same. It's an isosceles triangle. 2x plus 68 is equal to 180. Subtract both sides by 68. 2x is equal to 112. Divide by 2. X is equal to 56. Number 20. So since this is an isosceles triangle, therefore I know that 20 will equal to 4x minus 12. These are the two legs, okay? And so then I can add 12 to both sides. I get 32 is equal to 4x. Divide by 4. X will equal to 8. Since x is equal to 8, that means this is equal to 29. Because 23 times 8 plus 5 is 29. And this side over here is equal to 20. Alright, same idea. Base angles, this must equal to 45. Right, because these two legs are the same. So I can say 45 is equal to 6x plus 3. Subtract 3 from both sides. I get 42 is equal to 6x. Divide by 6, I get x is equal to 7. And since x is equal to 7, that means this must be equal to 29. Use a figure shown shown below to answer 22 and 23. Let's see here. 22. What is angle DEG and DFE? Oh, if DFE is equal to 70. DFE is equal to 70. DFE is equal to 70. So that means this is 70. So that means, wait a minute. It says that these two angles are bisected, right? And since these are both sides C here, that means these two sides are the same. That means this angle here must be 70. That means this is an isosceles triangle. And since I have, so let's call this x and x, right? So 2x plus 70 is equal to 180. 2x plus 140 is equal to 180. 2x is equal to 40. Divide by 2, x is equal to 20. So that means this is going to be 20 apiece. So DEG is equal to 20. And then what is the value of B if A is equal to 8 and C is equal to 24? So according to the isosceles triangle theorem, right, B is, what is the value of B? B is, this is B. This is going to be a right triangle. A is equal to 8 and C is equal to 24. So what is that? So this is actually going to be, we're going to be applying the Pythagorean theorem. 8 squared plus b squared is equal to 24 squared. 64 plus b squared is equal to, I don't know what 24 squared is, so let's just punch that into the calculator. 24 squared is equal to 576. B squared is equal to, I want to take 576 and minus 64. That's 512, and I'm going to take the square root of both sides. So 512. B is equal to square root of 512. So because it's not a perfect square, 512, is this divisible by 4? Yes, it is. That looks like it's divisible by 4 again. And it's divisible by 4 again. And one more time. So this is going to be 16. It's actually going to be 16 squared times 2. That makes 512. So really, B is equal to 16 square root of 2. Okay. Prove triangle ABC is a right angle. Angle ABC is a right angle. So if that's x here, and therefore this angle here is x, and if that angle is x, that means this angle over here, what will that be in terms of x? It's going to be 180 minus 2x. And since that's 180 minus 2x, what's this angle over here? This angle over here must be 2x. I don't know what these angles are. I want to call them y. So I know that 2y plus 2x, whoops, should equal to 180. Agree? I hear you guys saying agree. Divide both sides by 2. I know with x plus y is equal to 90. Right? But wait a minute. Angle B, angle ABC is equal to x plus y, right? So therefore, angle ABC is equal to 90. All right. Given PSR is equal to 134, what is the measure of angle SQR? So I don't know what this, PSR is equal to 134. So being that PQS is a equilateral triangle, this is going to be 60 degrees. I don't know what this angle is. I don't know what this angle is. But I do know that PSR angle PSR is equal to 60 plus x, which is also equal to 134. Therefore, x must equal to 74. Since x is equal to 74, and I'm asked to find out what SQR is, right? SQR is equal to 180 minus 2x, which is 180 minus 2 times 74, which is 180 minus 148, which is 32.